Precalc 9-135. It says, given f of x equals tangent x, use the fact that sine x plus y equals sine x cosine y plus cosine x sine y, and cosine x plus y equals cosine x cosine y minus sine x sine y to show this. So this is going to be a pretty long process, but basically, here's how you start. So I just started out, put this up here. I just started out by stating that, what they gave me. And then they're saying f of x plus h minus f of x. Well, if f of x is tangent x, then f of x plus h would be tangent x plus h. And then they said f of x was tangent. So there's my f of x all over h. Hopefully you're following that so far. So I don't have this side yet. I'm just looking right here. And I'm going to keep on working with this. Keep going on down the line trying to make it look like this, because that's what they're asking me to do when they say show. They say show that this can look like this. So I know tangent is sine over cosine. So I just turned my tangent right here into sine over cosine. Right? And I did it right here. And then I realized I have a fraction over a fraction, and I'm going to take that h out. Where did I do that? On the next page. So I factor the h out. Well, I factored out 1 over h, so I don't have to have it a fraction like fractions on complex fractions. And so then in this step, I used the fact, they told me, use the fact. These are basically my angle addition formulas that I have, okay? So they told me the sine x plus y was sine x cosine y, cosine x sine y. So see what I did? This is x and y, so I just traded it out. See this part right here? I just put in my, it's not the double angle formula, but it's my angle addition formula. And same thing with this one, because they told me that cosine, a plus b or whatever is cosine a cosine b minus sine a sine b. So I stuck that in there. And here's this. So take that all in. And then I keep reminding myself I'm trying to get it to look like this. So I got that factored out, so that's good. How is it going to end up looking like this? Well, I know I need a 1 on the top. Oh, I know what I did. I wanted to get a common denominator. So the common denominator would be this whole denominator times this denominator. And I didn't show much work, but see how I've got this times this whole thing? That's what this is down here. So I had to multiply the top and the bottom of this fraction by cosine x. So you can see it just kind of appears right there. Like I multiplied that and that by cosine x. So that's where that cosine x pops up from. See, it wasn't there, and then I multiplied the top and bottom by cosine x to get the common denominator. So I just stuck it right there. And then when I multiplied this one by cosine x, that's where I got the cosine x squared. And then this fraction would have to get multiplied by cosine x cosine h minus sine h. Basically, I have to multiply this fraction by the top and the bottom by a giant 1 of that. So, oops. So that's why there's an extra sine x. I got sine x, cosine h, and then sine x, well, when I multiplied the sine x by that, it made sine squared x, and it was a negative times a negative, so it's positive. Okay, so that, hopefully you can follow that algebra. It was just, I just got a common denominator for my fraction. I did a lot of it in my head. This is a pretty gnarly problem. And then what happened here? Oh, and I noticed that after I did all that hard work, I noticed these two cancel out. And I noticed that these two both have a sine h as a common factor, so I factored it out. And why did I do that? Because way back here, I knew I had to get a 1 up there somehow. I'm trying to end up with a 1 up there. So I know cosine squared x plus sine squared x is 1. So I just was just trying to get that to cancel out. And so that cancels out because that equals 1. But now I'm stuck with a sine h up here. So I decided to, like, divide the top and bottom by sine h, or you could say I multiplied the top and bottom by 1 over sine h. That gives me 1 over sine h times sine h equals 1. So, because I'm just doing whatever I have to do to get that 1 up there. And then when I multiply down here by 1 over sine h, when the 1 over sine h multiplies with cosine h, that gives me cosine h over sine h, which is cotangent h. So that's where that came from. And then when the 1 over sine h multiplies over here, this cancels out. So I get this nice. This is nice. And does that match? Is that what they asked me to have? Let's compare. They asked me to show that this ends up equaling this. So let's make sure. Okay, so we did what they asked us to do. That was just letter A. And then for letter B, they say, at this point, can you evaluate the limit as h approaches 0 of this function? Well, if I plug a 0 in there, I get undefined. Let's see, if I plug a 0 in here, cotangent of 0 is undefined. Oh, because this is the only place to plug a h in. So, and cotangent of 0 is undefined because cotangent is cosine over sine, and sine of 0 is undefined. So, so you're supposed to say for letter B, you're supposed to say no, because cotangent of h is undefined. Undefined. And that's because cotangent of h is cosine of h over sine of h, and sine of 0 is 0. So that was letter B. And then, so letter C, here's letter C. So letter C says, write the resulting equation when multiplying by tangent h over tangent h. So they want me to take what I had in the last part. Remember, I had that, and they want me to multiply by tangent h over tangent h. So just these two parts multiplied together give, oh, hold on a second. This tangent h times this cotangent h cancel out because they're reciprocals of each other. So this tangent h, I just wrote it up on top. This tangent h down here, it canceled out. And I just have h. And then I have everything down here. Oh, this tangent h times this Well, it's still there, isn't it? Okay, so that tangent h times this cancels out, and then when I times it by this, it gives me a tangent h. And then the top one times 1, that's just tangent h. So letter C, write the resulting equation. So that's what they got. And then letter D, what does letter D say? Letter D says, it is known that the limit as h approaches 0 of tangent h over h equals 1. Use this fact and your answer to part C to show that when the limit as h approaches 0 of f of x plus h minus f of x all over h for f of x equals tangent x is applied, the result is secant squared theta. So they want me to take the limit as h approaches 0 and my answer to part C. So there's my answer to part C. And then they want me to take the limit as h approaches 0. And they told me that the limit as h approaches 0 of tangent h over h, it is actually 1. So that's going to be 1 times the limit of this. So I didn't write the 1, but that's what it is. And then the limit of this as h approaches 0, the only place where we're going to plug an h in would be right here. So tangent of h, well, tangent of 0, tangent is sine over cosine. Sine of 0 is 0. So that actually kills this whole piece right here because it's 0 times cosine times sine. So that whole piece goes away, and then I have 1 over cosine squared x. And 1 over cosine squared x actually is equal to secant squared x. So that is some pretty gnarly algebra for you. And that's it.